Welcome back, traveler. Tonight we explore how Earth actually moves. It sounds like the simplest idea in astronomy, almost too obvious to question. Earth spins once a day. Earth goes around the sun once a year. That picture is tidy, familiar, and comforting. It's the version most people carry without ever feeling the need to look closer. After all, if the ground feels still beneath your feet, how complicated could its motion really be? For centuries, that simple picture felt complete. You wake up, the sun rises, you go to sleep, the stars drift overhead. The world feels solid, anchored, dependable. Even when you learn that Earth is spinning, it still feels like a technical detail, something true on paper, but irrelevant to daily life. You imagine a slow, graceful turn, like a globe on a classroom desk, moving just enough to explain day and night, but nothing more. But here's what most people don't realize. That calm picture is deeply misleading. Earth is not just rotating and orbiting in neat circles. It is moving through space in ways that are layered, tilted, stretched, and constantly changing. Motions that do not repeat cleanly, do not point in a single direction, and do not even agree on what forward means. Once you start stacking these motions together, the idea of Earth having a simple path quietly falls apart. If this is true, then up is not fixed in space. Still is not an absolute state. The direction Earth is moving right now depends on which frame you choose to care about. Time, as measured by motion, starts to blur. Navigation becomes a story of approximation. Even the idea of where Earth has been, or where it is going, becomes harder to define than intuition suggests. None of that will make sense yet, and it shouldn't. That confusion is part of the trail. By the end of this journey, you'll understand how Earth actually moves, not as a list of motions to memorize, but as a single, layered behavior unfolding inside a much larger system. You'll see why no simple diagram ever quite captures it, and why this matters for how we understand motion, reference frames, and our place in space itself. If you enjoy these calm, late-night explorations, you can like the video, subscribe to the channel, and leave a comment telling me where you're watching from and what time it is there. Those small signals help others find their way here too. Now, let's begin. The first thing to let go of is the idea that Earth's motion can be described from a single point of view. Most diagrams quietly cheat. They choose a convenient frame, lock the camera in play school, and pretend that frame is somehow special. From there, Earth spins. From there, Earth orbits. Clean arrows, smooth curves. But motion doesn't work that way. Motion is always relative to something else, and the moment you change what you're comparing Earth to, the story changes shape. Imagine standing on a moving walkway in an airport. Relative to the handrail beside you, you're standing still. Relative to the terminal floor, you're moving forward. Relative to the city outside, you're part of a much larger drift. None of these descriptions are wrong. They are incomplete in different ways. Earth exists inside that same stack of moving walkways, except the walkways are spinning, curving, accelerating, and embedded inside even larger flows you never feel directly. Start with the most familiar layer, Earth's rotation. At the equator, the surface is moving eastward at roughly 1,000 miles per hour, relative to Earth's center. That number sounds dramatic until you remember that you don't feel speed, you feel change in speed. There's no sudden push, no acceleration once the motion is established. But that quiet spin already means something important. Two people standing at different latitudes are not moving through space in the same way, even if they share the same moment in time. Now add the next layer. Earth orbits the sun, tracing a path that is close to circular but never perfectly so. Over the course of a year, Earth moves around the sun at tens of kilometers per second. That motion doesn't cancel out the spin beneath it. It stacks on top. Every point on Earth's surface is now following a looping, corkscrew-like path through space, spinning while orbiting, like a bead spiraling around a moving wire. But here's where intuition starts to break. That spiral only exists if you choose the sun as your reference point. Shift the frame again, and the shape warps. The sun itself is not fixed. It is moving around the center of the Milky Way, carrying Earth, the other planets, and everything else along with it. Suddenly, Earth's yearly orbit is no longer a loop at all. It becomes a wavering ripple embedded inside a much larger galactic motion. This is where diagrams often stop, because the picture is already messy enough. But stopping here gives the false impression that there is still a main direction, some cosmic forward that everything agrees on. There isn't. The sun's motion around the galaxy is influenced by the galaxy's mass distribution, by interactions with spiral arms, by subtle gravitational tugs that change over immense timescales. The path is not a clean circle. It's an evolving trajectory through a dynamic system. And even that is not the end of the stack. The Milky Way itself is moving relative to neighboring galaxies, drawn toward regions of greater mass, participating in flows that span millions of light years. On these scales, the idea of a single, stable background completely dissolves. Earth's motion becomes a nested pattern inside patterns, none of which can claim to be the final reference. At first, this sounds like an abstract complication, something that only matters to physicists arguing over coordinates. But it forces a deeper question. If Earth's path depends entirely on perspective, then what does it mean to say Earth moves at all? Which motion is the real one? The daily spin you never feel, the yearly orbit that defines seasons, the galactic drift that shapes the night sky over eons. This is the trap intuition falls into. It wants one answer, one true motion. But physics doesn't offer that comfort. Motion is relational. Every description is anchored to a choice, and every choice hides something else. Once you accept that, Earth stops being an object following a single path and becomes a process, a continuous negotiation between gravity, inertia, and the structure of the universe around it. And that raises a problem you might not expect. If Earth has no single in absolute motion, then how do we ever measure anything precisely? How do we define directions, predict eclipses, launch satellites, or synchronize clocks? The fact that we can do these things at all suggests that somewhere inside this shifting complexity, there is a workable order. Not a simple one, but a reliable one. Finding it took centuries, and it didn't come easily. For most of human history, motion was understood in the most direct way possible. If something moved, you saw it move. If something was still, it stayed where it was. A cart rolling across a room changed position. A thrown stone traced an arc through the air. A ship left the harbor and disappeared beyond the horizon. Movement in this view was something that announced itself clearly. And by that standard, Earth seemed stubbornly motionless. Stand on solid ground, and nothing suggests that the planet beneath you is racing through space. Drop a stone from your hand, and it falls straight downtown, not behind you. Fire an arrow upward, and it returns close to where it was launched. Clouds drift, birds fly, waves roll, but the ground itself never betrays any sign of motion. To early thinkers, this wasn't a mystery, it was evidence. If Earth were truly moving, surely something would give it away. This intuition hardened into a principle. Motion required a cause, and once the cause stopped, motion should stop too. A cart only rolls because something pushed it. A spinning object slows down unless something keeps it going. By that logic, a spinning Earth made no sense. What could possibly keep something so massive turning forever without tiring? And if it were spinning, why didn't everything on its surface get left behind? To make this concrete, imagine standing on the deck of a ship centuries ago, long before anyone spoke about inertia. If the ship suddenly lurched forward, you'd feel it immediately. Loose objects would slide. Your body would react. Now imagine the ship moving smoothly at a constant speed. If you had no view of the shoreline, no wind, no waves breaking the illusion, the motion would disappear. You could pour water, toss a coin, walk across the deck. Everything would behave as if the ship were still. That distinction mattered, even if no one had the language for it yet. Most people assumed that motion always felt like the first case, not the second. They didn't yet understand that constant motion can be invisible from the inside. And because Earth never felt like it was lurching, shaking, or dragging things behind it, the conclusion seemed obvious. Earth was not moving. Attempts to prove otherwise ran into the same wall again and again. If Earth rotates, then a cannonball fired north or south should land somewhere unexpected. If Earth spins eastward, then a dropped object should miss its target slightly as the ground moves beneath it. These ideas were tested in crude ways, often with frustratingly inconclusive results. The deviations were too small to detect with the tools of the time, drowned out by air resistance, human error, and imperfect measurements. Worse still, early astronomy didn't help. The stars appeared fixed, locked into rigid patterns that rotated as a whole around Earth each night. If Earth was spinning, that rotation should look different. If Earth were orbiting the sun, the positions of stars should shift over the year. But for a long time, no such shift could be measured. The sky looked stubbornly unchanged. Again, this absence wasn't treated as a puzzle. It was taken as confirmation. So the idea of a stationary Earth wasn't just philosophical. It was practical. It fit the observations. It fit everyday experience. It fit the physics of the time. And most importantly, it avoided uncomfortable consequences. A moving Earth implied a universe far larger than anyone was ready to accept, with stars so distant that their apparent stillness masked enormous scales. That idea felt extravagant, even absurd. But beneath this confidence, cracks were quietly forming. Sailors noticed something subtle when ships traveled long distances. Winds behaved differently than expected. Projectiles didn't always follow ideal paths. Pendulums showed small inconsistencies that refused to vanish no matter how carefully they were built. These weren't dramatic failures, but they lingered like loose threads, suggesting that motion might not be as simple as it seemed. Then came a deeper realization, one that didn't rely on better instruments but on better thinking. If you perform an experiment entirely inside a smoothly moving system, you cannot tell whether you are moving or at rest without looking outside. The behavior of falling objects, flying birds, and flowing water remains the same. The laws of motion don't care about constant velocity. This idea sounds obvious now, but at the time it was quietly revolutionary. Once you accept that, the silence of Earth's motion stops being evidence against it. The absence of strange effects becomes exactly what you should expect. A rotating, orbiting Earth would not betray itself through everyday mechanics. Everything on its surface shares the motion. The atmosphere moves with it. The oceans move with it. You move with it. The entire system is entirely consistent. But this realization created a new kind of discomfort. If Earth's motion is hidden so well, then how do you ever reveal it? How do you separate genuine stillness from perfect motion? The problem shifted from why don't we feel Earth moving to what kind of experiment could ever detect motion at all? That question haunted centuries of thinkers. Some proposed ever more delicate measurements. The others searched for cosmic reference points, something truly fixed that Earth could move relative to. The stars seemed promising, until their immense distances blurred the picture. Even the sun, once placed at the center, refused to act as an absolute anchor. It too was in motion. This is the moment where Earth's movement stops being a simple astronomical fact and becomes a philosophical problem. Motion is no longer about where something is, but about how descriptions change depending on where you stand. The idea of absolute rest begins to dissolve, replaced by a web of relative motions that only make sense within chosen frames. And that shift has consequences far beyond Earth. It reshapes how you think about speed, direction, and time itself. If motion cannot be detected from within a system moving steadily, then velocity loses its privileged status. Only changes in motion, accelerations, rotations, curvatures, leave fingerprints behind. Everything else becomes a matter of perspective. That insight didn't arrive all at once. It emerged slowly, through failed experiments, uncomfortable thought experiments, and grudging revisions of intuition. But once it took hold, it opened the door to a much stranger picture of Earth's motion. One where the planet is not tracing a single path through space, but participating in a layered dance defined entirely by relationships. And here's where things start to get strange. Because even when Earth's motion is understood as relative, there are still effects that refuse to disappear. Small, persistent deviations that only show up when motion curves, tilts, or accelerates. Those effects will eventually give Earth's movement away, not as a smooth glide, but as a complex, evolving pattern that leaves subtle signatures behind. That's the next problem waiting to be faced. If constant motion hides itself perfectly, then the only hope of detection lies in what constant motion cannot do. It cannot curve without consequence. It cannot rotate without leaving traces. And Earth quietly does both. Rotation is a different kind of motion. You can feel it even when speed itself disappears. A spinning platform pulls outward. A rotating wheel resists changes to its orientation. Unlike smooth travel in a straight line, rotation refuses to stay hidden. It introduces tension, distortion, and drift, subtle at first, but undeniable once you know where to look. Imagine standing on a wide, slowly spinning carousel. At the center, you feel almost nothing, but step outward, and the world changes. Objects released from your hand don't fall straight down. They curve. You feel a faint outward pull, not because something is pushing you, but because your frame of reference is twisting beneath you. The motion itself bends the rules of what straight means. Earth is that carousel, scaled up beyond intuition. Its rotation is steady, ancient, and astonishingly precise. But because Earth is so large, the effects of that rotation are spread thin. They don't announce themselves with force. They whisper. They accumulate, and when measured carefully enough, they refuse to go away. One of the earliest hints came not from astronomy, but from motion itself. Projectiles fired over long distances didn't land exactly where simple calculations predicted. The deviations were small, almost dismissible, but consistent. Something was nudging them sideways, not wind, not error, something systematic. At first, these discrepancies were treated as nuisances. Corrections were added, tables refined, but as measurements improved, a pattern emerged. The deviation depended on direction. Objects moving north or south curved differently than objects moving east or west. The effect scaled with latitude. Near the equator, it weakened. Toward the poles, it intensified. That pattern is the signature of rotation. From Earth's surface, everything is moving eastward, but not at the same speed. Points near the equator travel faster than points closer to the poles. When an object moves across latitudes, it carries its original eastward speed with it. The ground beneath it, however, does not match that speed. The result is a sideways drift, not because a force is pushing the object, but because the surface below is rotating differently. This effect doesn't feel real because it isn't a force in the traditional sense. It exists only because you are describing motion from a rotating frame, but its consequences are real enough. Air currents bend. Ocean flows twist into spirals. Storm systems rotate in opposite directions depending on which hemisphere they form in. These are not coincidences layered on top of weather. They are geometry expressed through motion. For a long time, this explanation felt unsettling. If Earth's rotation could shape winds and seas, then the planet's motion was no longer an abstract astronomical detail. It was actively sculpting life, climate, and navigation. The ground beneath your feet was not just moving through space, it was quietly steering everything that moved across its surface. Then came an experiment so simple it felt almost theatrical. A heavy pendulum, suspended from a high ceiling, set into motion. Left alone, it should swing back and forth in a single play-in. And it does, but only in space. Relative to Earth beneath it, that plane slowly rotates over time. The floor turns. The pendulum doesn't. Nothing pushes the pendulum sideways. Nothing twists the string. The only explanation that survives is that Earth itself is rotating underneath the swing. The pendulum becomes a silent witness, tracing the planet's motion without engines, without gears, without human intervention. This was different from cannonballs and weather patterns. This was clean, visual. Hard to argue with. Earth's rotation was no longer a matter of philosophical preference or astronomical convenience. It was measurable inside a building, using gravity and time alone. But even here, intuition fights back. The pendulum doesn't prove Earth is spinning through space, some argue. Only that the ground beneath it is rotating. But that distinction collapses under scrutiny. There is no meaningful difference. Rotation relative to what? If space itself offered an absolute grid, the pendulum would align to it. It doesn't. It aligns to inertia, to motion unforced by rotation, and inertia, unlike Earth, refuses to turn. This is the moment where Earth's motion gains teeth. Rotation introduces effects that cannot be erased by changing perspectives. They don't disappear when you ride along. They build structure into the world. They make some paths curved and others straight. They introduce preferred directions, not in space, but in motion. Once you accept this, the implications widen quickly. Earth's rotation affects how long days really are. It influences how satellites must be launched. It alters how time is measured across the planet. A clock at the equator does not experience motion the same way a clock near the poles does. That difference is tiny, but real and measurable. The idea that motion could influence time itself once sounded absurd, yet here it begins, quietly, not in distant galaxies, but in the turning of the ground beneath your feet. Rotation stretches paths, changes speeds, subtly reshapes durations. These are not philosophical curiosities. They are corrections engineers must include if they want systems to work. And that realization changes the tone of the entire story. Earth's motion is no longer hidden. It is no longer optional. It is active, shaping outcomes whether you acknowledge it or not. The planet is not just carrying you along, it is quietly setting the rules of the game. But rotation is only one layer. Earth's path is curved in more than one way. It does not just spin, it bends around the sun. That curvature introduces another class of effects, harder to detect, slower to accumulate, but even more profound in their consequences. Because once motion curves through gravity, space itself starts to participate. And when space participates, the story of how Earth moves becomes something far stranger than a spinning ball on a simple orbit. That's where the next fracture appears. Rotation explains why Earth quietly bends motion on its surface. But rotation alone is not what carries the planet through space. The deeper truth is more unsettling. Earth is not traveling around the sun in the way a car travels around a track. Earth is falling. That sentence tends to cause confusion because falling feels like a failure, a loss of support, something brief and terminal. But in space, falling can be endless. Falling can be stable. Falling can become a path. Imagine throwing a stone horizontally from the top of a tall tower. At first, it travels forward. At the same time, gravity pulls it downward. The farther it goes, the farther it falls. Now imagine throwing it faster. It travels farther before hitting the ground. Faster still, farther still. There is a speed where the stone keeps missing the ground entirely, not because gravity stops pulling, but because the surface curves away beneath it. That is orbit. Earth is doing exactly that around the sun. It is moving sideways fast enough that as it falls toward the sun, it never reaches it. The planet is perpetually dropping inward, perpetually missing, tracing a curved path dictated by gravity and momentum together. There is no engine holding Earth up. There is no balance point where forces cancel. There is only motion and curvature locked into a continuous negotiation. This reframes everything. Earth is not supported in space. It is not resting on anything. It is not held in place. It is in free fall, the most natural state motion can take under gravity. The only reason this fall looks smooth and repetitive is because the conditions are stable over long timescales. Once you see this, the idea of Earth's path changes shape again. An orbit is not a loop drawn on a page. It is a compromise between straight-line motion and curved space. If gravity vanished, Earth would fly off in a straight line. If sideways motion vanished, it would plunge inward. What we call an orbit is simply what happens when neither gets the final word. This is why orbital speed matters so much. Too slow, and Earth spirals inward. Too fast, and it escapes. The actual speed is not special because it is correct, but because it is what history left behind. The outcome of early chaos, collisions, and energy exchanges during the formation of the solar system. But here's where intuition slips again. That falling motion is not uniform. Earth's orbit is not perfectly circular. It stretches and compresses over time. The planet speeds up slightly as it moves closer to the sun, slows down as it moves farther away. Seasons are not caused by this. Tilt does that. But timing is. The length of months, the exact spacing of days, even the rhythm of the calendar are shaped by this uneven fall. And Earth is not alone in this dance. The moon is falling around Earth in the same way, carrying tides with it. Those tides are not simply water sloshing back and forth. They are a record of gravity stretching Earth itself, pulling oceans into elongated shapes that rotate as Earth spins beneath them. The result is friction, and friction steals energy. That stolen energy has consequences. Earth's rotation is slowing, imperceptibly but relentlessly. Days lengthen over geological time. The moon drifts outward, centimeter by centimeter each year. These are not theoretical predictions. They are measured. Laser pulses bounced off reflectors left on the moon return slightly later than they used to. Earth's motion is aging, changing its tempo as gravity reshapes the system. This matters because it shows that Earth's movement is not eternal or static. It evolves, it responds, it trades energy with its surroundings. The path Earth follows today is not the path it followed billions of years ago, and it will not be the path it follows billions of years from now. Zoom out further, and the picture complicates again. Earth does not orbit a stationary sun. The sun itself is moving, wobbling slightly due to the gravitational pull of the planets, tracing a complex path around a shifting center of mass. Earth's fall is not centered on the sun's surface, but on a moving point in space that exists only because multiple bodies interact. This means Earth's actual trajectory is never a clean ellipse. It is a constantly corrected curve, shaped by Jupiter's distant tug, by passing asteroids, by subtle gravitational nudges that accumulate over time. Most of these influences are tiny. None are zero. And now the truly strange part begins to emerge. In a curved orbit, straight lines lose their meaning. The idea of constant speed becomes slippery. Earth's velocity is always changing direction, even when its speed stays nearly the same. That change in direction is an acceleration. And acceleration, unlike constant motion, leaves fingerprints. Those fingerprints show up in timekeeping. A clock in orbit ticks differently than a clock on Earth's surface, not because it is broken, but because motion through gravity alters the flow of time itself. That idea sounds like it belongs much later in the story, but its roots are here, in the simple act of falling sideways. Engineers must account for this when building satellites. If they don't, GPS drifts, positions become wrong, navigation fails. Your phone's map depends on corrections born from Earth's orbital motion and the way gravity bends time along that path. What began as a story about where Earth goes has quietly become a story about how motion reshapes reality. Not in dramatic bursts, but in small, cumulative deviations that only matter because precision matters. And that raises another uncomfortable question. If Earth is falling, rotating, wobbling, and drifting through layers of motion at once, then what exactly defines its path? Is it the curve around the sun, the spiral through the galaxy, the subtle oscillations imposed by cosmic structure? There is no single answer. Earth's motion is not a line you could draw once and be done with. It is a story told across frames, scales, and forces, each valid within its own context, none privileged above the rest. This is the point where the old diagrams finally collapse under their own simplicity. Earth does not move like anything familiar. Every analogy breaks somewhere. Every picture hides more than it reveals. And yet, despite all this complexity, Earth's motion is predictable enough to send machines across the solar system, to land probes on distant worlds, to aim antennas across billions of kilometers and still hit their targets. That reliability is not accidental. It emerges from deeper order, rules that govern how space and motion interact at the most fundamental level. To understand those rules, we have to go one step further, beyond falling objects and spinning frames, into the structure that motion itself unfolds within. Because the next layer is not about how Earth moves through space. It's about how space moves with Earth. Up to this point, Earth's motion can still be imagined as something happening within space, a spinning body, a falling planet. Our curved path traced against a cosmic background. Even when those motions stack and tangle, there remains an unspoken assumption holding the picture together. Space itself is passive, a silent stage, a grid where motion happens, but which never participates. That assumption turns out to be the next thing that breaks. To see why, it helps to think about clocks. Not abstract clocks, but real ones. Devices built to count time by repeating a physical process over and over. A pendulum swinging, a quartz crystal vibrating, an atomic transition ticking with astonishing regularity. These clocks do not care about philosophy. They respond only to the conditions they experience. For a long time, time itself was treated as universal. A second here was a second everywhere. Motion changed positions, not durations. But once Earth's layered motion was measured with enough precision, that belief quietly failed. Consider a clock on Earth's surface and an identical clock aboard a satellite. The satellite is moving differently. It is higher in Earth's gravitational field. It is falling freely around the planet instead of being held up by the ground. None of this feels dramatic. And yet, when those two clocks are compared, they do not agree. The satellite clock runs faster, not by much. Nanoseconds. Fractions so small they feel insulting to worry about, but they accumulate. Left uncorrected, those tiny differences grow into kilometers of error in positioning systems. GPS would drift uselessly. Navigation would lie. Precision would collapse. This is not a glitch. It is not an engineering flaw. It is Earth's motion revealing something deeper. Gravity and motion do not merely bend paths, they alter time itself. At first, this seems disconnected from Earth's movement, but look closer. The satellite's path is different because Earth's gravity curves space around it. The satellite is following a straighter path through curved space than the ground beneath it. The clock feels that difference. Time responds. This is where the story becomes uncomfortable for intuition. If clocks tick differently depending on how they move and where they are, then time is no longer a background flow. It becomes part of the system. Earth's motion is not happening in time. It is shaping time locally. And Earth is not special in this regard. Any massive, moving body does the same. But Earth is where the effect becomes unavoidable, because we depend on precision here. The planet's motion is not just a cosmic curiosity. It is baked into the infrastructure of modern life. Every GPS calculation quietly corrects for Earth's rotation, its gravitational field, its orbital velocity, and the satellite's motion relative to both. These corrections are not optional. They are not aesthetic. They are required for reality to line up with maps. This forces a shift in how motion is understood. Earth is no longer just tracing a path through space. It is embedded in a structure where motion, gravity, space, and time are inseparable. You cannot adjust one without touching the others. The idea of a single trajectory now feels inadequate. Earth's path depends on how time is sliced, how space is measured, and which observer you imagine doing the measuring. A straight line for one frame becomes a curve for another. A steady tick for one clock becomes a drift for another. This is not because reality is subjective, but because it is relational. That word tends to get abused, but here it means something precise. Quantities like speed, direction, and duration do not exist on their own. They exist between objects, between frames, between paths. Earth's motion only becomes meaningful when compared to something else, and that something else is never fixed once and for all. At this point, it becomes tempting to ask whether Earth is moving at all in any absolute sense. If motion always depends on a reference, then maybe the question itself is flawed. Maybe Earth is not moving through space so much as participating in the structure of space-time itself. That idea feels abstract, but its consequences are concrete. The bulge of Earth at the equator exists because rotation reshapes gravity. Satellites must adjust their orbits because Earth's mass curves space. Time signals must be corrected because Earth's motion distorts duration. None of these effects vanish if you change your perspective. They persist because they are geometric, not subjective. And yet, despite this, Earth's motion remains astonishingly stable. Seasons repeat, orbits endure. Clocks can be synchronized well enough to guide aircraft and land spacecraft. The system holds together not because it is simple, but because it is deeply constrained. Gravity does not allow arbitrary motion. Curvature imposes rules. Energy trades one form for another, but the accounting must balance. Earth's movement is complex, but it is not chaotic on human timescales. It is legible, just not intuitive. This is where many explanations stop, content to gesture at relativity and move on. But stopping here hides something important. Earth's motion is not only shaped by local gravity and rotation. It is nested inside even larger flows, structures that stretch beyond the solar system, beyond the galaxy, into patterns that span hundreds of millions of light years. On those scales, motion stops being about orbits and starts being about drift, about large-scale structure, about invisible rivers of matter guiding entire galaxies along preferred directions. And Earth, quietly, is carried along with them. That realization pulls the ground out from under the last comforting illusion that somewhere, at some scale, there is a true rest frame, a place where motion stops, a cosmic stillness you could finally point to and say, "This is it." There isn't. Earth's motion does not terminate in simplicity. It dissolves into participation, into membership in a universe where everything moves relative to everything else, and the only constants are relationships. Understanding that does not make the world feel unstable. It makes it feel coherent in a deeper way. The predictability we rely on emerges not from stillness, but from constraint, from motion that is allowed only certain shapes. And Earth's shape of motion, spinning, falling, drifting, aging, is one of those allowed stories. But we're not finished yet, because there is one last layer where Earth's motion stops being about physics alone and starts to say something quieter and harder to ignore about where here actually is. That layer is not measured in meters or seconds. It's measured in perspective. What comes next is where the idea of Earth's motion stops being merely complex and starts becoming genuinely unsettling. There is no privileged place in the universe from which Earth's motion can be observed correctly. There is no external balcony, no cosmic sidewalk, no silent reference frame where someone could stand still and watch Earth move the way we watch a car pass on the street. Every description of Earth's motion is always made from inside a system that is itself already moving. That may sound abstract, but it is a concrete physical problem. Think about riding on a long, smooth train. If the train glides steadily, without vibration or jolts, you can walk down the aisle, pour a cup of water, even fall asleep without feeling motion at all. Inside the train, nothing tells you how fast you are moving. The motion only becomes obvious when you look out the window and compare yourself to something that is not sharing your movement. Now remove the window. There is no outside of the universe we can look through. Every reference we use, the ground, the sun, distant stars, entire galaxies, is already in motion. Each time we try to anchor Earth's movement to something supposedly stable, we discover that the anchor itself is drifting, rotating, accelerating, or being pulled by forces even larger. For most of human history, the stars seemed like the ultimate fixed background. They rose and set, night after night, but their relative positions barely changed within a lifetime. They guided navigation, marked seasons, and anchored entire cosmologies. To ancient observers, they appeared eternal and immovable. Earth, by contrast, seemed restless, but precision changed everything. As measurements improved, astronomers noticed that stars do move. Slowly, yes, but undeniably. Some creep closer, others drift away. Constellations that feel permanent are temporary arrangements, snapshots frozen within a narrow window of time. The night sky is not a painted ceiling, it is a slow-motion swarm, and Earth is embedded within that swarm. Our planet orbits a star that itself travels around the center of a galaxy. But even that description collapses under closer inspection, because the galaxy is not stationary either. It moves relative to nearby galaxies, pulled by vast concentrations of matter that we cannot see directly. The Milky Way is not an isolated island floating in emptiness. It is part of a group, which is part of a filament, which is part of a gigantic cosmic web stretching across the observable universe. Every layer carries the previous one with it. This means Earth's motion cannot be captured by a single curve and spiral or elegant diagram. Any illustration that tries to show how Earth moves is forced to freeze something that, in reality, never freezes. It must choose a viewpoint and pretend that viewpoint is neutral. But it isn't. What actually exists is closer to a continuous flow, where motion has no clear starting point and no final reference. Earth does not travel from point A to point B in any absolute sense. Its position is not a location, it is a relationship, temporary, conditional, and constantly renegotiated relative to everything else that exists. And this quietly changes the original question. How does Earth move? Turns out to be incomplete. The more honest question is, relative to what? Relative to the ground beneath your feet. You are motionless. Relative to Earth's center, you are rotating. Relative to the sun, you are falling sideways in an orbit. Relative to the center of the galaxy, you are racing through space at speeds that defy everyday imagination. Relative to the largest structures in the universe, you are being carried by currents so vast you will never feel them. All of these statements are true at the same time. None of them is the final truth. This creates a subtle discomfort. Our minds crave closure, a single correct description, a definitive frame, a sentence that ends with a period. But Earth's motion refuses that kind of ending. Each time you think you've reached the deepest layer, another level reveals itself beneath, already moving, already part of something larger. Even space itself refuses to remain passive. On the largest scales, space does not merely host motion, it expands. Distances grow not because galaxies are flying through space like debris in an explosion, but because the fabric between them is stretching. Some portion of Earth's motion is not a journey at all, but a consequence of space itself changing shape. This kind of motion has no local direction. It does not point forward or backward, up or down. It happens everywhere at once. It separates objects without giving them a path, and yet it is as real as any orbit or rotation. At this point, the everyday idea of motion begins to dissolve. Movement stops being about going somewhere and becomes about existing inside a dynamic geometry. Earth moves because space-time itself allows structures and enforces that movement. The planet is not an independent traveler. It is a participant. None of this announces itself to your senses. You do not feel galactic rotation when you wake up. You do not notice cosmic expansion while walking down the street. Your body evolved to survive within a narrow band of speeds and scales, and within that band, reality behaves politely. Outside it, reality keeps going. The fact that we cannot feel these motions does not make them philosophical curiosities. It makes them revelations about how limited intuition really is. We are creatures shaped by a slow, rotating rock, yet capable of uncovering patterns that no sense organ was ever built to detect. Seen this way, Earth's motion is no longer just an astronomical fact. It is a quiet demonstration that reality does not organize itself around perception. We organize ourselves, painfully and gradually, around reality. And that leads to a final tension we haven't resolved yet. If there is no fixed point in space, if all motion is relative, if even time responds to how things move, then what does it actually mean to be here? That question is waiting just ahead. What makes Earth's motion so difficult to grasp is not the speed involved, but the absence of rest. We grow up believing that motion is something that happens to objects, while stillness is the default state they return to when forces stop acting. A ball rolls, slows down, and eventually rests. A car accelerates, brakes, and comes to a stop. The world feels built on the assumption that motion is temporary and rest is fundamental. But the universe does not share that assumption. There is no experiment you can perform inside your room, with the windows closed and the air still, that can tell you whether Earth is moving or not. The floor beneath you feels solid. The walls do not drift. Objects remain where you place them. Everything about your immediate experience screams stability. And yet, at this exact moment, you are participating in multiple motions layered on top of one another, none of which announce themselves. This is not a limitation of technology. It is a property of reality. If you were sealed inside a perfectly smooth airplane flying at constant speed, every physical process inside that cabin would behave exactly as if the plane were parked on the ground. A dropped object would fall straight down, though a tossed ball would follow a clean arc. Your heartbeat, breathing, and balance would remain unchanged. Motion at constant velocity leaves no fingerprints inside the system it carries. Earth is doing the same thing. For centuries, this idea was deeply unsettling. It contradicted everyday logic. If Earth were truly moving, people argued, surely we would feel it. Surely objects would lag behind. Surely birds would be left behind in the sky. Surely something would betray the motion, but nothing did. The problem was never missing evidence. The problem was the assumption that motion must be detectable from within. What eventually emerged was a radical reframing. There is no physical state called absolute rest. There is only motion relative to something else. If two systems move together smoothly, neither can claim to be truly at rest while the other is moving. From the inside, they are indistinguishable. This reframing does not come naturally to the human mind. We instinctively anchor reality to the ground beneath our feet. We treat Earth as a stage rather than a performer, but physics does not grant Earth that privilege. Even the ground is moving. At first, this realization feels like a semantic trick. If everything is moving, then nothing is moving in any meaningful sense. But that intuition collapses the moment we introduce comparison. Motion reveals itself not through isolation, but through contrast. Differences matter. Relative speeds matter. Shared motion hides itself. This is why Earth's rotation went unnoticed for so long. The atmosphere rotates with the planet. The oceans rotate with it. You rotate with it. There is no internal resistance pushing against you, no friction announcing the spin. The system is coherent. The same is true of Earth's orbit around the Sun. You are not being dragged along a path. You are falling freely, continuously missing the Sun, tracing a curve through space-time that feels like stillness from within. Gravity does not feel like motion. It feels like weight. And even that sensation disappears in orbit. This is where the idea of motion quietly changes shape. Motion is no longer something you detect directly. It is something you infer by comparing perspectives. The universe does not provide a master reference frame. It offers only relationships, and those relationships depend on where you stand, or more accurately, how you move. But here's where the discomfort deepens. If there is no absolute rest, then there is no universal now either. Events that appear simultaneous in one frame are not guaranteed to be simultaneous in another. The ordering of moments becomes entangled with motion itself. Time stops being a global drumbeat and becomes something local, negotiated. At first, that sounds philosophical, but it isn't. The reason satellites must constantly correct their clocks is not because engineers are sloppy. It's because time genuinely passes at different rates depending on motion and gravity. A clock moving relative to Earth does not stay synchronized with one resting on the surface. A clock higher in Earth's gravitational field ticks differently than one deeper within it. These are not edge cases. They are everyday engineering constraints. Your phone's GPS works only because these differences are accounted for. Navigation relies on timestamps precise enough that even tiny mismatches would send positions drifting by kilometers. Without correcting for Earth's motion and gravity, the system would fail rapidly. This is where the idea of Earth actually moving becomes unavoidable. Movement is not just a path traced through space. It reshapes time. It alters synchronization. It changes what at the same moment even means. Earth's motion is written directly into the structure of cause and effect. And yet, nothing feels strange. You wake up. You drink water. You walk across a room. The sun rises. The sky turns dark. Life proceeds as if the universe was stable and slow. The deeper truth remains hidden, not because it is subtle, but because it is consistent. Reality does not glitch when intuition fails. It simply continues. This creates a quiet tension at the heart of physics. The universe obeys rules that do not align with perception, yet produces experiences that feel perfectly ordinary. We live comfortably inside a structure that, if described honestly, sounds impossible. Earth is not gliding through a static backdrop. It is participating in a choreography where space, time, and motion are inseparable. There is no still frame to pause on, no definitive diagram that captures the whole truth without distortion. And this raises a question we cannot avoid much longer. If motion changes time, and if Earth is always moving relative to something, then whose time are we actually living in? That question does not have an intuitive answer, and the closer we get to it, the stranger Earth's journey becomes. At some point, a natural question appears almost involuntarily. If Earth is always moving, then moving relative to what? And just as importantly, who gets to decide? This question sounds simple, but it quietly dismantles the idea that motion has a single objective description. We are used to thinking that there must be a correct answer hidden somewhere, a true path, a real speed, a final reference frame that settles the matter. But the universe refuses to offer one. Imagine standing on a quiet street, watching a car pass by. From your perspective, The car is moving, and you are not. Now imagine sitting inside that car, watching the buildings slide past the window. From inside, the car feels still and the city moves instead. Neither perspective is wrong. Each is internally consistent. Each describes reality accurately from its own frame. Now scale that idea up to Earth. From the surface, the ground beneath your feet feels immobile. The sun appears to rise and set. The sky rotates overhead. From this frame, Earth seems still, and the cosmos moves around it. Switch frames, and suddenly Earth spins, orbits, wobbles, and drifts while the stars remain comparatively fixed. Switch again, and even the stars are no longer anchored. The unsettling part is not that these descriptions disagree, it's that they are all correct. Physics does not ask which one feels more natural. It asks which one preserves the laws of nature. And remarkably, they all do. The equations do not break when you change perspective. Motion reshuffles, but causality remains intact. This is where intuition begins to slip. We want motion to be something absolute, like height or mass. We want to say Earth moves at this speed, along this path, through this space. But motion behaves more like language than like geometry. Meaning depends on context. Translation matters. If you measure Earth's motion relative to the sun, you get one elegant picture. A graceful orbit, nearly circular, repeating year after year. If you measure it relative to the center of the Milky Way, that orbit becomes a corkscrew, layered onto a much larger galactic rotation. If you measure it relative to nearby galaxies, the path bends again, influenced by gravitational tides and large-scale structure. Each description is mathematically valid. None is privileged. This creates a subtle but profound shift. Earth does not have a single motion. Motion is something assigned by an observer. Change the observer, and the story changes with them. At first, this sounds like relativism taken too far, as if physics has abandoned objectivity, but the opposite is true. This flexibility is what allows the laws of physics to be universal. They do not care where you stand or how fast you move. They care only about relationships. And yet, there is one tempting exception that often enters the conversation. If everything is relative, people ask, what about the universe as a whole? Surely there must be some grand backdrop, some cosmic frame against which motion can finally be judged. For a moment, it seems like modern cosmology offers one. The cosmic microwave background, the faint afterglow of the early universe, fills space almost uniformly. When we measure it, we find a subtle temperature difference depending on direction. One side of the sky appears slightly warmer, the other slightly cooler. This asymmetry reveals that Earth, along with the solar system and the galaxy, is moving relative to this ancient radiation. At last, it seems we have found it, a cosmic rest frame, a universal reference. But even here, the universe slips away. The microwave background does not define rest in a fundamental sense. It is not a law of physics. It is a historical artifact, the leftover light from a specific era. Useful, informative, but not authoritative. The laws of nature do not change if you move relative to it. No experiment suddenly becomes simpler. No principle demands alignment with it. It is a convenience, not a commandment. This distinction matters deeply. Physics allows us to choose reference frames, but it does not elevate one to absolute status. Even the largest, oldest structures in the universe fail to claim that role. There is no cosmic referee declaring who is really moving. What this means, quietly but decisively, is that Earth's motion is not a single story waiting to be told correctly. It is a family of stories, each valid within its own frame, each revealing something different. The Earth you imagine as tracing a smooth orbit around the Sun is not wrong. The Earth you imagine spiraling through the galaxy is not wrong. The Earth you imagine drifting with local cosmic flows is not wrong either. None of these pictures cancels the others. They coexist, and that coexistence carries a cost. If motion has no absolute meaning, then concepts we rely on, simultaneity, distance over time, even cause and effect across large scales, begin to blur at the edges. The universe becomes less like a fixed map and more like a network of overlapping viewpoints. This is not just an abstract inconvenience. It reshapes how we interpret observations. It explains why astronomers must constantly specify frames, corrections, and assumptions. It explains why speed in space is always accompanied by a relative to. There is no final sentence that reads, "Earth moves like this." There are only clauses. Earth moves like this relative to the Sun. Earth moves like this relative to the galaxy. Earth moves like this relative to the early universe. Each sentence is true. None is complete. And this fragmentation prepares us for the next, more unsettling realization. If motion depends on who is watching, and if time depends on motion, then even the flow of time we experience on Earth is not as universal as it feels. The clocks we trust, the rhythms we live by, are quietly entangled with the paths we trace through the cosmos. The Earth does not just move through space in different ways depending on perspective. It moves through time differently too. And that is where the story turns from geometry into something far stranger. If motion depends on perspective, then time quietly follows it. This is the part most people resist at first, not because it is complicated, but because it interferes with something deeply personal. You can accept that Earth spins. You can accept that it orbits the Sun. You can even accept that it drifts through the galaxy. But time feels different. Time feels intimate. It feels like something you carry with you. And yet time is not immune to motion. Imagine two identical clocks. One rests on a table beside you. The other is placed on a plane and flown around the world before returning to the same spot. When they are reunited, they do not agree. One has aged slightly less than the other. The difference is tiny, imperceptible to human senses, but undeniable. It has been measured, repeated, verified. The moving clock experienced less time. This is not a trick of engineering. It is not a flaw in the mechanism. It is a property of reality itself. Motion does not merely change where you are. It changes how much time you accumulate while getting there. Now scale this idea up to Earth. The surface beneath your feet is not stationary in any absolute sense. It is rotating eastward. It is orbiting the Sun. It is carried along by the Sun's motion through the galaxy. Every one of those motions contributes, however slightly, to how time flows for you compared to someone in a different frame. You do not notice this because everything around you shares the same motion. Your clocks agree with one another. Your biological rhythms stay in sync with your environment. There is no internal contradiction. But that harmony is local, not universal. A clock placed on a satellite orbiting Earth ticks at a different rate than one on the ground. Part of that difference comes from speed. Part comes from gravity. Together, they create a small but persistent divergence. If engineers did not account for it, satellite navigation systems would drift off course rapidly, accumulating errors that grow with every passing hour. This is not theoretical physics intruding into daily life. It is daily life depending on theoretical physics to function at all. The unsettling implication is that Earth does not carry a single global present moment. There is no universal now shared cleanly between the surface, orbitas, and deep space. Instead, there are overlapping layers of time, each flowing according to its own conditions. From your perspective, everything feels synchronized. From another perspective, it is not. This does not mean time is broken. It means time is relational. Just as motion depends on reference frames, time depends on trajectories through space. Change the path and you change the clock. Change the gravitational environment, and you change it again. Earth exists at the intersection of many such paths. A clock at the equator experiences slightly different conditions than one near the poles. A clock on a mountain ticks differently than one at sea level. These differences are small, but they are real. Earth's rotation, shake, and gravitational field all conspire to stretch and compress time in subtle ways across its surface. The planet does not experience a single uniform temporal rhythm. It hosts a mosaic of times, stitched together so smoothly that only precision instruments can detect the seams. And yet, those seams matter. They remind us that time is not an invisible river flowing independently of motion and mass. It is a dimension woven into the structure of space-time itself. The way Earth moves determines how it ages, moment by moment. This realization forces a quiet shift in how we interpret motion. Earth's journey through space is not just a path traced on a cosmic map. It is a path through space-time, and space-time responds. The faster the motion, the slower the clock. The deeper the gravity, the slower it ticks again. Earth sits between extremes, not fast enough or massive enough to produce dramatic effects, but not neutral either. It occupies a middle ground where relativity whispers instead of shouting. Those whispers accumulate. Over geological timescales, over astronomical distances, over technological systems that demand nanosecond accuracy, Earth's complex motion leaves measurable fingerprints. Time itself becomes a record of the path taken. This is why there is no privileged temporal perspective from which Earth's motion can be fully summarized. Any attempt to define a single timeline must choose a frame, and in doing so exclude others. The notion of a universal cosmic clock dissolves. What remains is a network of clocks, each honest within its own frame, each disagreeing politely with the rest. At first, this seems like a loss. We want simplicity. We want a master clock ticking somewhere in the background of reality, validating our experience. But the universe offers something stranger instead. It offers consistency without absolutism. The laws governing time are the same everywhere, but their expression depends on motion and gravity. Earth does not violate these laws. It exemplifies them. Its layered movement through space becomes a demonstration of how time adapts rather than resists. And this brings us back to the original intuition that Earth moves. That statement now feels incomplete. Earth moves, yes, but in doing so, it experiences time in a way that cannot be fully detached from that motion. The planet's clocks, natural and artificial alike, are participants in its journey, not passive observers. The more carefully you look, the harder it becomes to separate motion from duration, space from time, trajectory from experience. Earth is not just traveling through the universe, it is aging through it, unevenly, relationally, frame by frame. And if that is true for a planet, massive, stable, and familiar, then the deeper implication is unavoidable. Every motion you have accepted as obvious carries hidden consequences for how reality unfolds. and we are only beginning to see where those consequences lead. At first, it feels reasonable to ask a simple question. If Earth is moving, then where is it going? Not metaphorically, not philosophically, but literally. In what direction is Earth traveling right now through space itself? It's the kind of question that sounds almost childish, the sort of thing you might sketch with an arrow on a piece of paper. An arrow pointing forward, an arrow pointing somewhere. And yet, the longer you hold that question, the more it begins to slip away from you. The problem starts with something so familiar you rarely notice it. Every motion you experience in daily life comes with a reference. A car moves relative to the road. Train moves relative to the station. Even the clouds move relative to the horizon. Motion, as your brain understands it, is always framed against something that feels solid and still. Remove that reference, and movement becomes strangely difficult to describe. You can feel speed, acceleration, change, but direction starts to lose meaning. For centuries, people assumed the universe provided that reference automatically. Space itself was imagined as a kind of invisible stage, vast, silent, unmoving. Objects moved through it the way ships move through water. If that were true, then Earth's motion should be easy to define. Just find the background that never moves, measure Earth's path against it, and draw the arrow, problem solved. But that background never revealed itself. Astronomers searched for it indirectly, without always realizing what they were looking for. If Earth were moving through a fixed cosmic medium, then light should behave differently depending on the direction you measure it. Just as sound changes pitch depending on motion, light should show subtle shifts if there were a universal frame of rest. Experiment after experiment looked for this effect. And experiment after experiment came up empty. No matter how carefully the measurements were made, no direction stood out as special. That absence wasn't just puzzling, it was unsettling. It suggested that motion itself might not work the way intuition demands. Because if there is no fixed background, then asking where Earth is going becomes like asking where a wave is going inside the ocean. The wave moves, yes, but only relative to the water around it. And the water itself is already in motion, shaped by currents, tides, and the rotation of the planet beneath it. Earth's movement is layered in exactly that way. Earth spins relative to its own axis. It orbits the sun relative to the solar system. The sun moves relative to the stars of the Milky Way. The Milky Way drifts relative to nearby galaxies. Each layer adds speed, curvature, and direction, but none of them provides a final reference. Remove one layer, and another remains. There is always motion beneath the motion. Here's where intuition breaks. You might try to solve the problem by picking the largest frame available. Perhaps the distant galaxies, perhaps the faint background glow of the universe itself. Surely that must define a true direction. And yet, even that choice is arbitrary. The universe does not label one frame as correct and all others as wrong. Physics works just as cleanly in any of them. If that's true, then Earth does not have a single trajectory through space. It has countless trajectories, all equally valid, depending on which frame you choose to care about. In one description, Earth traces a gentle spiral around the sun. In another, it weaves a complex path as the solar system curves through the galaxy. In another still, Earth barely moves at all, while the rest of the universe flows around it. None of these descriptions is privileged. None of them is the real one. And that realization forces something else to give. If there is no absolute motion, then being at rest is not a fundamental state of the universe. Rest is local, temporary, contextual. You are at rest relative to the chair beneath you, but not relative to the air drifting through the room. You are at rest relative to Earth's surface, but not relative to Earth's center. Each statement is true and incomplete at the same time. This is why diagrams of Earth's motion often feel unsatisfying, even when they are technically correct. They compress something deeply relational into a single arrow, and that arrow quietly lies. It suggests finality. It suggests certainty. It suggests a destination. But Earth is not headed anywhere in that sense. It is participating in motion embedded within it, never stepping outside the system to observe itself from a neutral vantage point. Once you see this, even familiar phrases start to sound strange. Earth is traveling through space. Through what exactly? Space is not a substance you move through like air or water. It does not resist, flow, or stand still. It does not mark your passage. Motion through space is not like crossing a landscape. It is a relationship between objects that never resolves into a single picture. And here's where it gets stranger still. If there is no absolute motion, then speed itself is also relational. Earth's speed is different depending on which question you're asking. Faster than the surface beneath your feet, slower than the particles raining down from space. Both statements are true. Neither is complete. Speed, like direction, refuses to settle into a single value. At first, this sounds like a philosophical annoyance, wordplay, semantics, but it isn't. Entire systems of navigation, measurement, and prediction depend on choosing frames carefully and switching between them without error. When spacecraft navigate the solar system, they do not rely on one universal map. They move between overlapping descriptions, each useful only within a certain range. Mistakes here are not abstract. They lead to missed targets and silent probes drifting forever into darkness. So which frame is really right? That's the trap. The universe does not answer that question because it does not recognize it. Motion has no master reference. There is no cosmic arrow labeled true direction. Earth moves in many ways at once, and none of them is more real than the others. And that realization quietly prepares you for what comes next. Because once motion loses its absolute meaning, time is no longer guaranteed to behave the way you expect either. The loss of a universal direction is only the beginning. Once you accept that motion has no absolute direction, another assumption begins to crack quietly beneath your feet. It is one you probably never questioned, because it feels so deeply woven into daily experience that it barely registers as an assumption at all. The idea that there is a single, shared present, one universal now that sweeps across Earth, the sun, distant stars, and everything in between, like a perfectly synchronized clock hand moving forward for the entire universe at once. It feels obvious. You check the time, someone else checks the time, and even if the numbers differ, the moment itself feels shared, the same instant, experienced from different places. This sense of a global present is so strong that it survives long after you stop thinking about clocks altogether. You imagine events unfolding across space as if they are all happening on the same invisible stage, lit by the same spotlight of now. But that spotlight depends on something you have already lost. To define a universal present, you need a universal frame. A way to say which events, separated by vast distances, are happening at the same time. And that definition quietly assumes a background that is not moving, a reference that allows you to slice the universe into neat layers of simultaneous moments. Once that background disappears, so does the guarantee that now means the same thing everywhere. At first, this feels like a technical problem, not a physical one. Surely you could just use light signals. Send a flash, wait for the return, synchronize clocks, and declare the present. That seems reasonable, until you remember what motion already took away. Light does not behave as a messenger tied to any particular frame. Its speed is stubbornly the same, regardless of how you move. And that single fact turns synchronization into a subtle trap. Imagine two distant clocks, far apart in space. You try to synchronize them by sending a light pulse from the midpoint. The pulse reaches both clocks, and you set them to the same time. Simple. But now imagine the entire system is moving relative to something else. Not absolutely, but relative to another observer. From that other perspective, the light does not reach both clocks at the same moment. One clock is moving toward the light, the other away from it. The synchronization breaks, not because you made a mistake, but because at the same time is no longer a shared concept. This is not an illusion. It is not a measurement error. It is a structural feature of reality once absolute motion is gone. What feels like a single present fractures into many. Each observer, moving differently, carries their own slice of now. And those slices do not line up cleanly. Events you consider simultaneous may already be in the past or future for someone else, even if neither of you is accelerating, even if both of you are moving smoothly and calmly through space. This is where intuition begins to protest. Surely this can't matter for Earth. The differences must be tiny, negligible, something you can safely ignore. And in everyday life, you usually can. The effects are small at human speeds and distances, but small is not the same as non-existent. The structure is there, waiting, and it becomes impossible to ignore once precision matters. Earth, moving through layered motions, rotation, orbit, galactic drift, does not carry a single universal clock with it. Every motion slightly reshapes which distant events count as happening now. The faster the relative motion, the more pronounced the disagreement becomes. Time does not break suddenly. It shears gently, like layers of fabric sliding past one another without tearing. Here is the unsettling part. There is no privileged layer, no correct slice, no master clock hidden somewhere in the universe, keeping everyone honest. The present is local. It belongs to a path through space-time, not to space itself. Earth's now is valid, but only for Earth, moving the way it moves. If that feels abstract, consider how deeply it alters the meaning of cause and effect. If there is no universal present, then there is no universal ordering of distant events. Some sequences that look fixed from one perspective become ambiguous from another. The universe does not collapse into chaos. Causality is preserved, but the clean, intuitive ordering you expect quietly dissolves. This is why diagrams of space-time often replace arrows with tilted planes. What looks simultaneous in one frame appears slanted in another. The tilt is not decoration. It encodes the loss of a shared present. Each observer carries their own now, angled differently through the fabric of events. Earth is embedded in this geometry whether you think about it or not. As it moves, it continuously defines its own present, slicing through the universe in a way that no other moving system shares exactly. There is no cosmic agreement to appeal to, no external judge to settle disputes about which distant events are happening right now. And yet, nothing feels wrong. Days pass, seasons turn, life unfolds without protest. This is the most dangerous aspect of the truth. Reality continues to function perfectly, even as your intuitive picture fails. The universe does not warn you when your mental model is outdated. It simply stops cooperating with it when pushed too far. Technology discovered this long before philosophy caught up. Systems that rely on precise timing cannot pretend that time is universal. Satellites orbiting Earth experience time differently than clocks on the ground, not just because of gravity, but because of motion. They're now drifts. Left uncorrected, this drift accumulates into errors that grow large enough to matter. Navigation fails. Positions blur. The abstract fracture becomes a practical problem. But even here, notice what does not happen. Engineers do not search for the true time of the universe. They do not attempt to recover an absolute present. Instead, they manage relationships, corrections, translations between frames. Reality is navigable not because it offers a single truth, but because it remains consistent once you stop demanding one. So when you ask how Earth actually moves, you are no longer just asking about paths and speeds. You are asking about how Earth carries time with it. How its motion reshapes what now means. How the planet's journey is not traced through space alone, but through a four-dimensional structure where movement and time are inseparable. This is the point where many explanations stop. They present the loss of a universal present as a strange but contained result, something to marvel at briefly before moving on. But stopping here hides the deeper consequence. Because once time itself becomes relative to motion, then motion begins to affect more than direction and clocks. It begins to touch the limits of what can influence what. If different observers disagree about simultaneity, then the boundary between cause and effect becomes something that must be carefully protected, not assumed. And the universe does protect it, but in a way that introduces an even stranger idea. One that quietly sets a maximum speed, not as a technical limit, but as a structural necessity. And here's where it gets strange again. Once the idea of a shared present collapses, the universe faces a quiet but serious problem. It is not philosophical, it is structural. If different observers disagree about what events are happening now, then there must be a rule that prevents those disagreements from turning into contradictions. Without such a rule, cause and effect would become negotiable. Events could rearrange themselves depending on perspective. The universe would not merely be strange, it would be inconsistent. And consistency is something reality refuses to give up. To see why, imagine a signal traveling between two distant events. One observer says the signal was sent first, then received. Another observer, moving differently, might see the order shift. If motion alone were allowed to reorder events freely, then it would become possible, at least from some perspectives, for an effect to occur before its cause. That is not just unsettling, it is fatal to any coherent notion of physics. So something must intervene, something must draw a line. That line is not drawn in space, it is drawn in speed. There exists a maximum rate at which influence can travel. Not because the universe is slow or inefficient or technologically limited, but because allowing anything faster would break the fragile agreement that keeps cause before effect for everyone, everywhere. The limit is not about light as an object. Light merely reveals it. The limit is about information, influence, and the ability of one event to affect another. Once this limit exists, the chaos retreats. Different observers may disagree about when distant events happen, but they will never disagree about which events can affect which others. The structure holds. Cause and effect remain intact, not because time is universal, but because influence is constrained. This is why the speed of light appears everywhere in physics, even in places where light itself is irrelevant. It shows up in electromagnetism, in space-time geometry, in the behavior of particles that have nothing to do with photons. The constant is not a property of light alone. It is the conversion rate between space and time, the slope of reality's fabric. Earth's motion is now embedded in this structure. Every rotation, every orbit, every drift through the galaxy unfolds inside a space-time where influence spreads at a finite speed. Earth does not just move through space. It moves through a network of causal relationships that are limited, directional, and asymmetric. This changes the meaning of distance. A faraway star is not merely far because it occupies another location. It is far because its ability to affect Earth is delayed. Its presence is inaccessible. Its influence arrives as an echo, shaped by the time it takes to cross the intervening space. Distance becomes temporal as much as spatial. And now consider what happens when Earth itself is moving. Signals arriving from different directions do not merely travel different distances. They interact with Earth's motion through space-time. The planet does not sit still waiting for the universe to speak. It meets incoming information at angles defined by its velocity. What Earth can know and when it can know it depends subtly on how it moves. This is where the idea of a rest frame quietly dies for good. There is no frame in which Earth can declare itself truly stationary with respect to causality. No motion peels away the limit. No clever maneuver restores a universal clock. The rules apply equally, relentlessly to all paths. At human scales, this feels irrelevant. At cosmic scales, or as it is everything, astronomers do not observe the universe as it is now. They observe layers of history. Every direction is a different time slice. The sky is not a snapshot. It is a collage of delayed information stitched together by the finite speed of influence. Earth moves through this collage, continuously changing which paths it is intersecting. Even the idea of simultaneity on Earth becomes fragile under scrutiny. Two events occurring far apart on the planet can be synchronized only approximately and only by agreement. The deeper truth is that simultaneity is a convention, not a feature. A useful fiction that works because the planet is small compared to the structure it inhabits. But scale the problem up just a little, and the fiction cracks. Earth's orbit around the Sun already introduces measurable differences in how time flows for systems moving differently. Earth's rotation creates tiny but real asymmetries between east and west. None of these effects are dramatic in isolation, but they accumulate. They whisper the same message again and again. Motion and time are entangled, and entanglement demands limits. This is why no object with mass can reach the speed that defines the causal boundary. Approaching it would require reshaping time itself in ways that reality refuses to allow. Clocks slow, lengths contract, energy requirements climb without bound. These are not obstacles to be engineered around. They are warnings written into the structure. Earth does not come close to this limit, but it lives inside a universe governed by it. Every movement of the planet is constrained by a rule that exists not to restrict motion, but to preserve order. The speed limit is not about preventing travel. It is about protecting sequence. Here's the deeper implication, one that rarely gets stated clearly. The universe does not privilege places. It privileges relationships. What matters is not where Earth is,
but how it is connected, causally, to the rest of existence. Movement reshapes those connections, but cannot break them. And this is where a subtle shift occurs in how you should think about motion. Earth is not tracing a path through an empty container called space. It is participating in a dynamic structure where motion, time, and influence define one another. The planet's trajectory is not a line.
It is a history. If that sounds abstract, it becomes brutally concrete when things go wrong. Signals sent too late cannot undo events that have already crossed the causal boundary. No speed, no technology, no ingenuity can retrieve information that never had time to arrive. The universe is not cruel about this. It is simply consistent. So when you ask how Earth actually moves, you're now confronting something larger than astronomy. You're asking how Earth participates in causality itself. How its motion determines which parts of the universe are reachable, knowable, or forever out of contact. Most explanations stop at the speed limit and move on. But stopping there misses a crucial realization. A limit on influence does not just protect the past from being rewritten, it also shapes the future by defining what interactions are even possible. And once you start thinking in those terms, the next question becomes unavoidable. If influence is limited, and Earth is always moving, then Earth is not just traveling through space and time. It is continuously redefining the set of futures it can possibly encounter. That is not a metaphor, and it is where the story becomes even more unsettling. Earth does not move like a bead sliding along a wire. That image suggests reversibility, as if the planet could simply retrace its steps and return to a previous state. But real motion does not behave that way. Every movement Earth makes through space also carries it forward through a web of cause and effect that cannot be undone. This is the part that intuition resists. When Earth rotates, nothing about that rotation is isolated. Heat shifts, oceans respond, air circulates, chemical reactions proceed. When Earth orbits the Sun, gravitational relationships subtly redistribute energy throughout the system. When the solar system moves through the galaxy, it passes through regions of space with different particle densities, magnetic environments, and radiation fields. None of this happens in a vacuum. Every motion leaves a trace. Those traces matter because the universe keeps a record, not in a book, but in its structure. Once an interaction occurs, it cannot be unoccurred. Once information spreads outward at the maximum allowed speed, it cannot be gathered back. Earth's past positions are not simply locations left behind. They are events that have already influenced everything they could influence. The planet is dragging an expanding wake of consequences behind it, whether anyone notices or not. This is why motion and time cannot be separated. To move is to commit. Every step forward narrows the set of futures that remain available. You can feel this on human scales. A spoken sentence cannot be unsaid. A dropped glass cannot be undropped. Even if the pieces are reassembled, the original state is gone. Earth operates under the same rule, just across scales that dwarf intuition. Its movement continuously selects which futures survive and which disappear forever. The unsettling part is that this selection happens without intention. Earth does not choose its path. Gravity, inertia, and cosmic structure guide it. But choice is not required for irreversibility. All that is required is interaction. And Earth interacts constantly, with sunlight, with solar wind, with the gravitational tug of distant bodies, with the background fabric of space-time itself. This means there is no cosmic rewind button. No coordinate system exists in which Earth could be said to be heading back to an earlier state of the universe. Even if its position repeated, the surrounding conditions would not. The universe would remember. This idea quietly undermines another comforting assumption, that the universe is symmetrical in time. At a fundamental level, many physical laws do not care which direction time flows. but the accumulation of interactions does. Entropy increases, information disperses, causal chains lengthen. Earth's motion feeds this asymmetry relentlessly. The planet's path through space is also a path through increasing complexity. This becomes especially clear when you consider communication. A signal emitted from Earth spreads outward, thinning as it goes, diluted across an ever-growing sphere. Even if Earth stopped transmitting entirely, the universe would still carry the echo of its past signals forward. There is no way to call them back, no way to erase their influence once they cross the causal horizon. Now scale that idea up. Every physical interaction Earth participates in radiates consequences outward. Gravitational disturbances propagate. Electromagnetic changes ripple through space. Even tiny variations, imperceptible locally, become part of the universe's evolving state. Earth is not a passive passenger. It is an active contributor to cosmic history. This is why the idea of Earth moving through space is incomplete. The planet is also moving through possibility space, collapsing options as it goes. Each moment selects one future and eliminates countless others, not through intention, but through inevitability. And here's where the discomfort deepens. There is no preferred timeline against which this progression can be judged. No master clock marking whether Earth is early or late. The only measure that exists is causal order. What can affect what tasks and when. Earth's motion determines which regions of the universe can still interact with it, and which have already passed beyond reach. Some stars visible tonight are already gone. Some events happening now will never be known here. The planet's future interactions are constrained not by distance alone, but by timing. This creates a quiet horizon around Earth, not a physical wall, but a boundary of relevance. Beyond it, events may occur, but they are causally disconnected. They might as well not exist, as far as Earth is concerned. That horizon is not fixed. It shifts as Earth moves. Every change in velocity slightly reshapes which events lie inside Earth's causal future. This is not dramatic on daily timescales, but across cosmic spans it becomes decisive. Earth is continuously redefining the slice of the universe it can ever influence or be influenced by. This turns motion into something weighty. Not morally weighty, but structurally. Movement carries consequence not because it is fast or slow, but because it is irreversible. Earth's trajectory is not just where it goes, it is what it makes impossible afterward. Most explanations of planetary motion never touch this. They stop at orbits and speeds, as if those numbers were the story. But those numbers are just the surface. Underneath lies a deeper truth. Earth is writing itself into the universe, one moment at a time, without the ability to erase previous lines. And once you see motion this way, a final tension emerges. If Earth is constantly committing to one future among many, and if influence is limited by speed, then there must be parts of the universe whose futures are no longer accessible to Earth, not because they are far away, but because the window has already closed. That realization changes what now means in a fundamental way. And it leads directly to the last block before the conclusion, where all of this converges into a single, unsettling question about perspective, limits, and what it really means for Earth to exist inside a moving universe. Here is the final fracture in intuition, and it is the quietest one of all. Every attempt to describe how Earth moves assumes something it never actually has, a privileged point of view. A place from which motion could be measured absolutely. A cosmic balcony where someone could stand and say, with authority, "This is what is really moving." That place does not exist. No matter how carefully you try to describe Earth's motion, you are always forced to choose a reference. Relative to the ground beneath your feet, Earth is still. Relative to the sun, it traces an ellipse. Relative to the galaxy, it follows a slow looping path. Relative to the cosmic background, it drifts in yet another direction entirely. None of these descriptions are wrong. None of them are complete. The unsettling part is that there is no final layer underneath them. There is no hidden coordinate system that all others reduce to, no universal grid etched into space itself. Motion does not have a true version waiting to be discovered. It only has relationships. This is deeply counterintuitive because everyday experience trains you to believe in absolutes. A parked car is not moving. A thrown ball is. A spinning object can be measured against the room around it. But all of those judgments quietly rely on shared frames that feel stable, only because everything nearby is moving together. Earth gives you that illusion constantly. The ground feels fixed because you are embedded within its motion. The air, the buildings, the horizon, they all participate. Your senses evolved inside a moving system and learned to treat it as stationary, not because it is Gule, but because questioning it offers no survival advantage. Physics, however, does not grant that convenience. When scientists began measuring motion beyond Earth, the absence of a universal reference became impossible to ignore. Every experiment that tried to detect absolute movement through space failed. No orientation, no velocity, no clever setup could reveal a background that refused to reveal itself. This wasn't for lack of ingenuity. It was because the question itself was flawed. Motion thou not exelst without comparison. Earth is not moving through space in the way an object moves through a room. Space is not a container sitting still while things slide inside it. Space is part of the relationship. When Earth moves, space participates. When time passes, it does so differently depending on how that movement unfolds. The deeper implicism is unsettling but precise. There is no external story of Earth's motion that outranks all others. Any description that feels authoritative is authoritative only within its chosen frame. Change the frame, and the story changes with it, not because reality shifted, but because perspective did. This is why diagrams of Earth's motion often feel misleading. Spirals, helices, looping paths. Each one suggests a kind of objectivity that doesn't really exist. They are useful visualizations, not revelations. Each diagram smuggles in an invisible observer whose rest frame is treated as special without justification. The universe never agreed to that framing. Instead, the universe offers something stranger and more demanding: consistency without hierarchy. All valid frames must agree on outcomes, even if they disagree on descriptions. Causality remains intact. Physics holds. But the idea of a single, correct picture dissolves. This reframes what it means to ask how Earth actually moves. The word actually implies a final answer, a correction to all approximations. But there is no correction coming. The approximations are all there is, layered, conditional, context-dependent. Earth's motion is not a single trajectory waiting to be revealed. It is a family of trajectories, each tied to a chosen relationship. This realization carries a quiet philosophical weight, but it is not abstract. It has practical consequences. Technologies that rely on timing, navigation, and synchronization must account for relative motion precisely because no frame is privileged. Systems like satellite navigation work only because they respect this relational structure, not because they ignore it. Earth itself lives inside this structure constantly. There is no cosmic narrator describing its journey from the outside. There is only the network of interactions it participates in, gravitational, electromagnetic, causal, each defining motion locally, temporarily, relationally. And here is the final, unsettling symmetry. The same is true for you. Just as Earth has no absolute motion, you have no absolute position in the universe's story. You exist inside relationships, not above them. Your now is local. Your sense of rest is contextual. Your trajectory is defined by what you are embedded in, not by a cosmic standard. This does not make motion meaningless. It makes it precise. Earth moves exactly as it must, relative to what it interacts with, no more, no less. There is no hidden truth behind that statement, no deeper correction waiting to overturn it. The strangeness is not that Earth's motion is complicated. It's that the universe refuses to give you a final vantage point from which to judge it. And once that sinks in, the original question transforms. You were never really asking how Earth moves. You were asking whether there is a place in the universe where everything finally makes sense from the outside. There isn't. And that realization, quiet, structural, unavoidable, is what makes Earth's motion not just a mechanical fact, but one of the strangest things we have ever discovered. At the beginning, this all sounded simple. Earth spins, Earth orbits, Earth moves. It felt like a list you could memorize and move on from, the kind of thing taught early because it seems harmless, settled, finished. A rotating sphere, a circling path, a steady journey through space. Nothing about that picture suggested danger or depth. It felt complete, but it never was. What you've really been following this whole time is not a path through space, but a boundary of understanding. Earth does not move in one way. It moves in many ways at once, none of them privileged, none of them final. Its motion depends on what you compare it to, when you observe it, and which relationships you choose to care about. Remove those choices, and the idea of motion itself starts to dissolve. The strange part is not that Earth's movement is complex. The strange part is that the universe refuses to tell you which description is the right one. There is no cosmic grid behind the scenes, no fixed background where everything else is measured. No universal stillness hiding underneath the motion. Earth is never simply moving through space. It is always moving with something, relative to something, because of something. Once you see that, the question, how does Earth actually move, changes meaning. It stops being a request for numbers or diagrams and becomes a question about limits. Limits on perspective, limits on simultaneity. Limits on what it even means to say now or here on a cosmic scale. Earth's motion is not a line you can draw. It is a relationship you participate in, and that may be the strangest thing of all. Not that Earth is spinning at incredible speeds, or racing through space, or leaving an irreversible trail behind it, but that there is no place outside the universe where all of this can be seen at once. No final frame where everything settles into a single, satisfying picture. The universe offers consistency, not comfort, structure, not hierarchy. Earth moves undeniably, but it moves without an audience, without a center, without a final reference point to make the story feel complete. And yet, here you are, standing on a planet that never rests, carried by motions you never feel, embedded inside a universe that refuses to stand still for your intuition. The ground beneath you feels solid, the night sky feels calm, and everything seems quiet. But beneath that calm is a choreography so deep and relational that no single perspective can capture it. That doesn't make the universe hostile. It makes it honest. If this journey helped you see that honesty more clearly, take a moment to like the video and subscribe. And if you feel like it, leave a comment saying where you're watching from and what time it is. A small marker of position and moment inside a universe that never stops moving. And now, with all of that settled just enough, you can let the question rest. Not because it's answered completely, but because you finally know why it never will be.